Last time we started our investigations on geology, the study of rocks. We were studying calcite and how calcite reacts with vinegar. And we learned that the eggshell has calcite, and when we put that eggshell inside of vinegar, it actually wore away all of the eggshell, right? And there are rocks that contain calcite, and we learned that if rock contains calcite, well, it can be worn away if placed in vinegar. Now, to follow up with that, we're going to introduce the bigger topic of what it means when something gets worn away. What we're going to start talking about today is weathering, and in particular, chemical weathering. Now, chemical weathering is when a rock is altered. It's changed. Maybe its color is changed, its texture is changed, its size is changed, but due to chemicals. And those chemicals are chemicals that are found either in the air or in our water. I'm going to show you a picture of rocks that have gone through chemical weathering. When you look at these 4 photos, what do you notice? What do you see? What do you observe? The colors are different, right? This is a mountain. Mountains are made out of rocks. They are different colors. The colors have changed somehow. Even the second picture, the third and the fourth, and they don't look all identical. They're not all uniform. Maybe some parts of the rock were more affected than other parts of the rock. In just a minute, we're going to do 3 different experiments that are going to demonstrate chemical weathering. For this lab, you will need 6 pennies. If the pennies are from before 1982, that would be great. You will need Alka-Seltzer and a pipette from your enrichment bag. You will need salt, vinegar, water, 4 plastic cups, 2 pieces of paper towel, and 2 other larger containers, plastic containers. You will also need a piece of wool, like an SOS pad. The first experiment we are going to start with is the effects of acid rain on copper-bearing rocks. Now, our pennies, remember I told you better before 1982? And that's because before 1982, the copper content was higher than it is today. So you need 6 pennies total. And we're going to have 2 cups. In these 2 cups, you're going to place 3 pennies in one, 3 pennies in the other. You're going to sprinkle a little bit of salt and nothing in the other. And our source of acid rain is our favorite acid, vinegar. And so I'm going to pour vinegar, making sure just to cover the pennies. And so this is going to be our experiment, but alongside the acid rain, we need to compare it with non-acid rain, which would be pure water. I'm going to put the same amount of water that I put in there, and I'm going to let these 2 cups sit for 24 hours. Once 24 hours have passed, now I'm going to bring my 2 containers. You can use any containers, a bowl is fine, anything. You're going to place your paper towels inside of the container. And your timing does not have to be exact. A little bit longer, a little bit shorter is fine. Now I'm going to just wet the bottom of my paper towels with vinegar in one, and remember, water in the other. We're doing everything exactly the same. The only thing that's different between these 2 experiments, the one variable that's changing is the rain, the acid rain versus regular rain. So remember, we had these pennies in pure water, and we had these pennies in salt and vinegar. And the reason we added the salt is that it speeds up the reaction a little bit. So once your pennies have been sitting in the cup for 24 hours, you're going to transfer them onto the paper towels. Remember, this paper towel has vinegar in it, and this paper towel has water in it. And then you're going to let them sit for about 3 days, and making sure to watch them. Each day. Now, while these pennies are resting, remember, these pennies are in vinegar and these pennies are in water. Make a guess, make a hypothesis, predict what you think will happen to the pennies. Now remember, this is an experiment to see the effects of acid rain on copper-bearing rocks. For this next part, we want to see the effect of water on rocks that contain iron inside of them. Now for this experiment, you're going to take a piece of steel wool. This is an SOS pad, but another steel wool pad will work as well. This is what we use to scrub our pots and pans, but they do have metal in them. They have iron inside of them. So what you're going to do is take it and break it into 2 pieces. Place one in one cup and place one in the other cup. Now what you're going to do is you're going to add water to one, and you're going to leave the other one just with air. Let's pour the water in. Just make sure it's submerged. And you can leave this for about 3 days as well. Now is a good time to, again, make a prediction, make a hypothesis, what you think will happen to both of these steel pads. One is sitting in water and one is sitting in just a cup with just air. Go ahead, make your predictions now. Now, for this last experiment, what we're going to see is we're going to see the effects of water on carbonate-containing rocks, and in particular, carbonate-containing rocks of different sizes. You will take your Alka-Seltzer and you can open it, making sure to leave the tablets intact. you're going to take one tablet whole and place it into the cup. And you're going to take, with the second tablet, you're going to break it into at least 4 pieces. If you can get it into even smaller, maybe 6 pieces, that would be best. And then just drop it into your cup. Now what we're going to do is we're going to see the effect that water has on these tablets. Again, this is an Alka-Seltzer tablet which contains carbonate, like calcium carbonate. What I'm going to do is you're going to add water. You're going to add 3 pipettes of water to the first cup and 3 pipettes of water to the second cup, and watch what happens. Before you do, make a prediction, make a guess, make a hypothesis as to what you think will happen. And do you think both of these cups will look exactly the same? We are now going to go over the results. So it's a good time to pause this video and make sure that your hypothesis is completed. So the first thing we're going to look at are the pennies that we put in vinegar and the pennies that we put in water. You can see the pennies that we put in water didn't really change color. They look about the same. Still have some marks on them, but relatively the same. And now let's look at the pennies we put in vinegar. Whoa, what happened here? They turned green, right? Let me take one out. Green and a little bit blue all over. And even the paper towel that it was soaking in became a little bit green too. Does acid rain have an effect on copper-bearing rocks? Sure does. Changes their color. Can you think of another copper fixture that we've seen, maybe in pictures, that is now green and is no longer copper color? The next experiment that we're going to look at is the effect of water on iron-containing rocks. And this was my steel wool that was just in air. Really not changed. Looks exactly the same. And let's look at the one that was sitting in water. I'm going to take it out of the water so we can take a closer look. Well, look at that. That certainly does look different. Look at the color difference. Now again, this is iron sitting in water. You can see the water dripping down also has some color with it, but there was definitely a color change here. This is what we call rust. There was a chemical reaction where the metal, the iron, changed color, and now it is this rust color. Imagine if there are rocks that contain iron inside of them, and there's just regular water that comes down. What happens to the color? Now, for the last experiment, we want to see the effect of water on carbonate-containing rocks and carbonate-containing rocks of different sizes. So I'm going to take my pipette, going to add 3 pipettes. Oh, you see fizzing. That's 2. And the fizzing is a sign of a chemical reaction. That's 3. I'm going to add 1, 2, 3. And then we're just going to wait until all the fizzing stops.
Okay, the fizzing has almost stopped. And let's look at our first, the big one, the carbonate containing rock. Did it change in size? Oh yeah. Let's see if we can get it out. And then let's look at our other one. I see two tiny, really tiny pebbles. I don't know if I can get them out without. There we go. That's one. Well, I'm only able to get one out. Now let's compare what the before looked like and the after. We started with one full tablet and compared. Did it change size? It sure did. Did it get smaller? Did it change texture? Did it change shape? And we had 1, 2, 3, 4, 5, 6 pieces. And those look like it's almost gone. It's not even there anymore. It has completely dissolved. Which one reacted faster? Well, the smaller Alka-Seltzer pieces. They had so much more surface area to react with. But nevertheless, both of them did get a lot smaller. Now imagine if a rock contains carbonate inside of it. What's going to happen to that carbonate when water comes in contact with it? It's going to wear it away and dissolve. One of the pictures we saw earlier looked just like this, right? Tiny little holes. I'm going to bring this a little bit closer so you can see. Do you see the texture? Very different than what it was before.
Now, just to recap, we were doing experiments on chemical weathering. We did 3 back-to-back experiments that demonstrated 3 different types of chemical weathering. The first one that we did was using pennies because they contain copper inside of them, and to see the effects of acid rain on them. Vinegar was our acid rain that we used today. And what happened? We saw a color change. Now for weathering to happen, for it to be chemical weathering, we need a chemical reaction. Color change is one of those examples of chemical reactions. Color change is one. And what happened with the steel wool? Was it a chemical reaction? It was. We saw a color change again, right? So we saw color change in 2 of our experiments, but this was a little bit different. This wasn't the effect of acid on copper. It was just the effect of water on iron. Imagine if you've walked around neighborhoods and you've seen iron products and they've been sitting outside. Maybe they've been hit by water and they will rust just like this, and that's a chemical reaction. And the evidence here, just like the pennies, was the color change. And then finally, with the Alka-Seltzer, did we have a color change? We didn't. How do we know it was a chemical reaction? Because we saw the fizzing, we saw the bubbling, and fizzing is also another sign of a chemical reaction. Now with these, we saw a change in texture and a change in size. One more way that you can have a chemical reaction is if heat is produced or heat is taken away. We couldn't do it, we couldn't examine with any of these, but in many chemical reactions, you will be able to feel the effect of heat being released. Now today we did experiments on chemical weathering. Please make sure to record your observations on your observation sheet.